Today's lesson is on exploring transformations of parent functions. We're continuing with the transformations and we're going to look at vertical stretches and compressions and horizontal stretches and compressions today. I have here three functions. The first one is y equals x squared minus 4. Second is y equals 2 times brackets x squared minus 4. And the third one is y equals negative 0.5 brackets x squared minus 4. So as you can see that there is a parent function which is x squared minus 4 and transformations have been made to it, so to get these two functions. I made a table of values going from negative 3 to positive 2 for each of them and recorded the y values. And what you notice is that when you go from the parent function or the beginning function to the next one here, which is 2 times brackets x squared minus 4, every y value is twice of what the y value was here, which means there is a vertical stretch by a factor of 2. So that's what happens when you multiply a function, the entire function, with a variable, in this case 2, then that function stretches by that amount or that many times as that variable. So your ordinate pairs are now x comma 2 times what they were here, 2 times y. Similarly here, what I noticed is for the same values of x, the y values had become half of what they were in here and also negative of what they were here because of the negative and the half over here. So what's happening to the x comma y, it's becoming x comma negative 0.5 times y. So this value that you're multiplying the function with is called its vertical stretch. This negative in this example is the reflection in the x-axis or the vertical reflection. I have sketched the graphs of the three functions. As you can see, the one in red is the beginning function or the given function, which is x squared minus 4. So it is the quadratic with the vertex at 0 and negative 4. And then when you vertically stretch it to 2 times x squared minus 4, you notice that the graph kind of becomes less as wide as it was. It becomes less wide, becomes thinner. So it's getting stretched by a factor of 2, which is why its shape has changed. Similarly, the next example was negative 0.5 times x squared minus 4. So the negative means there will be a reflection of the x-axis, which is why the graph is opening down. And you can see it's wider than the parent function, and that is because of the vertical compression of 0.5. Okay, so this third graph, the one in green, has two transformations. One is its reflection, its vertical reflection or reflection in the x-axis, as well as that it has been vertically compressed by 0.5 or 1/2. And this one here, 2 times x squared minus 4, has been vertically stretched by a factor of 2. So it's become much more thinner, whereas this one has become more wider. So when you compress a graph vertically, it becomes wider than the beginning function, and when you stretch it, it becomes kind of leaner and thinner. Okay, so you can see the shape of a graph changes when you do a vertical stretch or compression. So if you're given a function f of x, describe what will happen if you did this to it. So if it became 2 times f of x plus 5, that means you do a vertical stretch of 2 and you translate it up by 5 units. If f of x becomes negative 3 times f of brackets x plus 2, then there are 3 transformations happening: the negative, the 3, and the plus 2. The negative means there's a reflection in the x-axis or a vertical reflection. There's a vertical stretch by a factor of 3, and there's a horizontal translation of 2 units to the left. Okay. In the third example, y over 3 is equal to f of x plus x minus 1. It's rearranged, so you get y equals 3 times f of x minus 1. So the 3 means there is a vertical stretch by a factor of 3, and x minus 1 means the graph has now moved 1 unit to the right. Okay. In example 3, you're given the equation of the pre-image function, and you're given some transformations, and you have to say what would the new equation of the image function look like. So y equals x squared has a vertical stretch of 4 and has vertically shifted down 3 units. What does it look like now? Well, because it's a vertical stretch of 4, it becomes 4 times x squared, and then minus 3 for the shift down. Y equals x cubed plus 2, vertical shift down and vertical stretch by 4. There's a vertical shift down by 3, by the way. That's not mentioned here, but by 3. So because the vertical stretched by 4, you multiply the entire x cubed plus 2 with 4 to show the vertical stretch. The entire function gets multiplied by that factor. And then this one here is vertical shift down by, we have -3 here, so it has, it should be y equals 4 times x cubed plus 3. Let's make it vertical shift down by 5 units, okay? And then just change the answer here. What would it look like? It would be y equals 4 times x cubed plus 2, and it's vertically shifted down by 5, so that's what it would look like. So it becomes 4x cubed plus 8 minus 5, so that becomes 4x cubed plus 3. So that's the new image functions equation. Y equals root of x, square root of x, vertically stretched by 1/2, and reflect the x-axis. So reflect the x-axis makes it a negative, and stretch by 1/2 makes it 0.5. So negative 0.5 root x. So in summarizing, when you do vertical stretches and compressions, if the a value is greater than 1, then you call it a vertical stretch. And if it's between 0 and 1, you call it a vertical compression. And if it's less than 0, it's negative. That means there's a reflection in the x-axis. That is the homework for this section. We're also going to go to horizontal stretches and compressions. And we're going to start with the absolute value of parent function, y equals absolute value of x, and compare that to absolute value of x divided by 3, and a third function, absolute y equals absolute value of 2 times x. So I made the table of values, and as you can see here, it goes from -2 to +2. But in the second table of values, I went from -6 to +6. And in the third table of values, I went from -1 to +1. So the reason that the x values are changing is because when I do this to the x, that is, I multiply the x by a factor, I get what is called a horizontal stretch or a compression. And the thing with horizontal compressions and stretches is that it's kind of the opposite in terms of is it being stretched or compressed. So if it is x divided by 3, it's divided by a factor of 3, that means it actually ends up in a horizontal stretch of 3. Okay, so the division by 3 results in a stretch by a factor of 3. And in this case, if it's 2 times x, it actually gets compressed by 1/2. So it gets compressed by 1/2. So that's the difference between vertical and horizontal stretches. So if it is x divided by 3, then it's actually getting stretched times 3. And if it is times 2, it's getting stretched divided by 2. So you'll find that in y equals absolute value of x divided by 3, my new ordered pairs will be 3 times x, 3 times whatever the value of x is, comma y. And for this one here, because of the compression, the x values become negative 0.5 times x, comma y. For the same y values, you can see how the x values are, in this case, being stretched by a factor of 3, and this case, compressed by a factor of 1/2 and reflected. Sorry, it's not reflected, it's just compressed by a factor of 1/2. I have also done the graphs of those 3 functions. This is the parent function, y equals absolute value of x in red. When you do x divided by 3, you see that the graph becomes wider. It's kind of stretched horizontally from what it was here. It kind of gets pulled this way, stretched, so it comes down like this. That's what happens when you do x divided by 3. It actually gets stretched by 3. And this one here in green, it's actually leaner. It's getting more compressed. It's being pushed, to become more less wider. So that's why it's compressed by 1/2. Okay, so it's been pushed that way and compressed. So it is becoming 1/2 of what it was originally. So given a function y equals f of x, describe what happens when these transformations occur. So if it becomes f of 2x minus 2x plus 5, the fact that there's a 2 multiplied with the x, that means there is a horizontal compression of 1 over 2. And the plus 5 means it's a vertical translation of 5 units up. If it becomes minus f of 3x, there's two things happening, the negative and the 3. The negative means there's a reflection in the x-axis, or a vertical reflection. And the 3 times x means it's compressed by 1/3. For y plus 7 equals f of x divided by 4, I rearranged it to get y equals f of x over 4 minus 7. So there's two transformations. One is the x divided by the 4 and the minus 7. Divided by 4 means there's a horizontal stretch by a factor of 4, and minus 7 means it's been vertically shifted down 7 units. So given these equation for the pre-image function and the transformations, come up with the equation of the image function. The first one, you have y equals x squared has gone through a horizontal stretch of 4 and has shifted down 3 units. What does the equation look like? So now it's, because it's stretched by 4, you have to divide x by 4 in the equation and square that, minus 3. In the second example, x cubed plus 2 has been stretched by 4 and shifted left 3. So again, x divided by 4 to show the horizontal stretch. Moving to the left 3 means plus 3 squared, and the plus 2 remains. Y equals square root of x, going through a horizontal stretch by 1/2, and a reflection of the y-axis. So reflection of the y-axis affects the x, so that becomes negative. And because it's horizontally stretched by 1/2, you have a 2 times x happening. So y equals square root of negative 2x. So in summarizing, when x is multiplied by a k value, then there is a compression of 1 over k. Okay, so that's what you will remember. Whatever the k value, so the k value is 2, then the stretch is 1 over 2. If the k value is 1/2, then the stretch becomes 2 times that. Okay, so that is the homework for horizontal stretches and compressions. That brings us to the end of this lesson.